All right. So we're just going to start with question number 1, and we're going to work our way through the entire review. Don't be alarmed that there are questions that are cut out. There are 16 questions, even though they number all the way into the 20s. So question number 1 says, draw a line AB and ray XY so that they intersect in a 90-degree angle. Make sure to label your diagram. So we need line AB. So I'm going to say this is line AB. Remember, for this to be a line, it has to have arrows on both ends. And for it to be line AB, somewhere on it, it's got to have an A, and somewhere it's got to have a B. So right there's line AB. Then we want ray XY that intersects at a 90-degree angle. So I'm going to draw ray. Remember, for a ray only has arrows, or an arrow on one end. Let's see, this is ray. I'm going to say that's X, and somewhere up here I'm going to put Y. So there's ray XY. I'm going to put my little box in here that says, hey, this is a 90-degree angle. It's a perfect corner. So there's line AB, ray XY that intersects at a 90-degree angle. So really 2 perpendicular lines. That's it for question number 1. Question number 2 says, using the diagram from question number 1, if the slope of AB is -2, what is the slope of XY? So for this, we have a slope of -2/1, and we're talking about perpendicular lines. When we talk about perpendicular lines, we flip the fraction and change the sign. Well, the original was negative, so mine I want positive, then I'm flipping the 2/1 to be 1/2. Thanks. So the slope of XY is going to be positive 1/2. We took that -2, made it a fraction, and flipped it over. Question number 3. So, find the perimeter of a figure with the following vertices. So we're given ordered pairs 0, 2, -4, 2, -2, -1, 6. We're going to use the distance formula 3 times. So you've had a test question like this before. It's just a different set of ordered pairs. So first thing I'm going to do is just graph them. So to graph 0, 2, start at the origin, go left or right 0, and then up 2. To graph -4, -2, left 4, down 2. And then -1, 6 up here. And then remember, to find the perimeter, in this case, we have a triangle. We need to figure out the length of all the sides. So we're going to have to use the distance formula. The distance formula is something I would definitely want to A, have memorized, or B, write on my cheat sheet for my test. So for those of you working on your cheat sheet while we do this, make sure you jot this down. You might write yourself a note. You're definitely going to need it for question number 3 on your final. So first thing I'm going to do is find the distance between the first 2 points, 0, 2, and -4, -2. So using my formula, I need x1 minus x2, 0 minus -4. As soon as I see that minus a -4, I'm changing it to a positive. Then I'm taking y1 minus y2, 2 minus -2. Again, as soon as I see that double negative, I'm changing it to a positive. Then I'm going to combine like terms in my parentheses. 0 plus 4 gives me 4. 2 plus 2 gives me 4. So now I have the square root of 4 squared plus 4 squared. 4 squared is 16, plus 4 squared is again 16. So now I have the square root of 16 plus 16, which is the square root of 32, which is approximately 5.7. So that tells us that this distance here is 5.7. But to find the perimeter, we have to find the length of all the sides. So we get to go back, use the distance formula again with 2 different points. So I'm going to go back and use the next 2. So I'm going to use -4, -2 with -1, 6. Label them x1, y1, x2, y2. And then we're again filling out our formula. In my formula, I need x1 minus x2. So x1 is -4 minus x2, which is -1. Again, as soon as I see that double negative, I'm changing it to a positive. For my second set of parentheses, I need y1 minus y2. That would be -2 minus y2, which is 6. Simplify inside your parentheses. So -4 plus 1 is -3. -2 minus 6 is -8. Square both terms. -3 squared means -3 times -3, which is +9. And -8 squared is -8 times -8, which is +64. Combine like terms, 9 plus 64 is 73. So I'm going to calculate the square root of 73 in my calculator to get approximately 8.5. That tells me this distance here is approximately 8.5. And then we get to repeat this process one more time with the first ordered pair and the last ordered pair. So these two. So label them x1, y1, x2, y2. And then again, we're following the same process. Plug into our distance formula. So in my distance formula, I need x1 minus x2, so 0 minus x2 is -1. Again, double negative changes to a positive. For the second part, I need y1 minus y2. y1 is 2 minus y2, which is 6. For our next line, we're going to simplify inside our parentheses. So 0 plus 1 is 1. 2 minus 6 is negative 4. Once I've simplified inside my parentheses, I'm going to square. 1 squared means 1 times 1, which is 1. Negative 4 squared means negative 4 times negative 4, which is positive 16. Combine square root of 16 plus 1 is 17, which is approximately 4.1. So now we've found the length of all three sides of our triangle, which really just means to find the perimeter, you're going to add them all together. So your perimeter is going to equal 5.7 plus 8.5 plus 4.1. So 18.3 would be the perimeter of that triangle. Questions on this one? So this one, my suggestion would be write down the distance formula for your cheat sheet and then try to keep your work as organized as possible. Moving to the back side, we're jumping to question number 6. Question 6 says solve for x, and then they give you a triangle. So triangle ABC, you're given the angle A equals x minus 6, angle C is 55 degrees, and then angle B has a little box in it. That little box tells you that's a right angle or 90 degrees. Then you need to know that the sum of interior angles of any triangle have to equal 180. So you're going to take angle A plus angle B plus angle C. If I add those all together, it's got to equal 180 degrees. So we're just going to replace parts with the information that we know. We know that angle A is x minus 6. Plus, we know angle B is 90 degrees. Plus angle C is 55 degrees, and they have to add all together to equal 180. So really, once you set this problem up, it's just a simple algebraic equation that you need to solve. First thing I would do to solve this is combine these like terms here. When I combine -6, 90, and 55, I get 139. So really, I have x plus 139 equals 180. Subtract 139 from both sides. And x equals 41. That's all I was asked to do. So that is my final answer. Questions on number 6. Question number 8 says, what makes an equilateral triangle different from other triangles? Draw a picture to support your answer. So an equilateral triangle has all sides and angles congruent. If I draw a picture to support that, I'm going to draw an equilateral triangle. Where can I draw it? I'm going to draw it out here. So there's my equilateral triangle. You must show me that this is congruent to this, which is congruent to this. There's all three sides congruent. And then I'm going to do the same thing. This angle is congruent to this angle and is congruent to this angle. So I've marked all three sides congruent, all three angles congruent in my diagram. Keep in mind, on your test, it might not say equilateral triangle. It might say isosceles. It might also say scalene, so you need to know the difference between all three of them. So equilateral, isosceles, or scalene triangles. Should be able to talk about the sides and the angles of each of those. Questions on this one? Oops. Question number 9 says solve for x if the measure of angle Q is 77 degrees. First thing I'm going to do is I'm going to take that 77 and I'm going to put it up there for angle Q. Think back to question number 6. We have a triangle. We're given information about all the angles. All the angles must add up to 180 degrees. So angle Q plus angle R plus angle S has to equal 180 degrees. Go back through and fill in the information that you know. Angle Q is 77 degrees plus angle R is 4x plus angle P, I don't know why I wrote S, P, angle P equals 7x minus 18, and all of those added together have to equal 180. Again, once you set this up, it's just a basic algebraic equation that you need to simplify and solve. So first thing I would suggest, combine like terms. So I can combine these two terms, 7x and 4x, give me 11x. I can combine these two terms, 77 minus 18 is positive 59. Haven't done anything with that 180, so we're just bringing it down. So now we have 11x plus 59 equals 180. If we're trying to get x by itself, we've got to get rid of that 59 first. Subtract 59 from both sides. When I subtract 180 minus 59, I get 121. And the last step to get x by itself, x is currently being multiplied by 11. So to get rid of the 11, I'm going to divide by 11 to get an answer of x equals 11. So 121 divided by 11 is 11. For question number 10, we're being asked to solve for x and then find the value of each angle. So first thing you've got to know is the relationship between the two angles you were given. So looking here, if I look at the position, so this is kind of on the left side of that intersection right here. This one's also on the left side. They're on the same side of the transversal in the exact same position, which means they're corresponding angles. And corresponding angles are always congruent. They're equal to each other. So this angle is congruent to this angle, which means 3x plus 42 has to equal the other angle, 4x plus 45. So again, another algebraic equation that you need to solve. Get your x's all on one side, your constants all on the other. So to solve this, I would first of all subtract 3x from both sides to cancel this one out. leaving me with 42 on the left. On the right side, 4x minus 3x, 4 minus 3 is 1. Haven't done anything with the plus 45. Again, trying to get that x by itself, we've got to move the 45. It's being added, so I have to subtract it from both sides. 42 minus 45 is negative 3. So negative 3 equals 1x, or x equals negative 3. That is only part of my answer. So my instructions say solve for x and then find the value of each angle. So we're going to take that x value and we're going to plug it back in. Doesn't matter which angle you plug back into because, again, they should be equal to each other because they're congruent. So if I just plug into this bottom one here, I would have 4 times negative 3 plus 45. So negative 12 plus 45 gives you a value of 33 degrees. So both of these angles have to be 33 degrees. Questions on this one? Moving to question number 12. Ooh. Looks like question number 12 has been moved. This should be in here. So at some point it's moved when I deleted things. So move that 2x plus 42 down here. Not sure how it got moved, but it did. So the 2x plus 42 is not supposed to be up here. It's supposed to be down there. I'll have to fix that. So unlike question number 10 that we just did, these two angles are not corresponding. They're not in the same spots at the intersection. One's on the right side, the other one's at the top. This is talking about this angle here. So these two angles are same side interior. So they're on the same side of the transversal here. So they're both on the top of the transversal. They're interior because they're inside the two parallel lines. So same side interior are not congruent. They are supplementary, which means they add to equal 180 degrees. So I'm going to take 2x plus 42 plus the 55. And since they're supplementary, they have to equal 180 degrees. And like a lot of problems, we've just created an algebraic equation that we need to solve. First of all, we're going to combine like terms. 42 plus 55 combined to give you 97. Then subtract 97 from both sides. That gives you 2x equals 83. Beside it, divide both sides by 2 to get an x value of 41.5. And this question only asks you to solve for x. It does not ask you to go back in and find the values of either angle. right, question 16, using the mid-segment theorem, find the value of segment XY. To do this, the first thing you've got to do is figure out what X is. So you're gonna have to use your rule of a mid-segment. Remember, mid-segment tells you that if you take the inside the mid-segment, multiply it by 2, it'll equal the side that it's parallel to on the outside. So 2 times the inside mid-segment 2x plus 3 has to equal the length of the side parallel to it, 5x minus 7. And again, we've created an algebraic equation for us to simplify and solve. So to get rid of these parentheses, we're going to distribute the 2 inside. 2 times 2x is 4x, and 2 times 3 is 6. Leave the right side alone. I would subtract 4x from both sides. So 6 equals x minus 7. Add 7 to both sides. So 13 equals x, commonly written as x equals 13. So now we've found x, but the question wants to know the value or the length of segment xy. So we have to go back to segment xy and substitute that 13 in. So 2 times 13, which is what we got for x, plus 3 is going to give us the value of segment xy. So 2 times 13 is 26. 26 plus 3 is 29. So line segment XY has a length of 29. Questions on this one? Moving to question 17, you need to know the difference between congruent and similar triangles. How are they the same and how are they different? So congruent and similar triangles are the same, that, whoops, they all have congruent angles. Or they both have congruent angles. So both similar and congruent triangles, oh, let's have equal. Let's do equal instead of word. Oh. So if I have a pair of congruent angles and a pair of similar triangles, both pairs would have equal angles to each other. Where things get different, congruent triangles must have all the same sides. So congruent triangles so for me to have a congruent triangle, if I have one triangle with sides 3, 4, 5, the other triangle must also have side lengths of 3, 4, 5. However, if you have a similar triangle, they don't have to be exactly the same. So similar triangles have proportional sides. Questions on these two? Moving to question number 18. Can you prove these triangles congruent by angle, side, angle? So looking at angle, side, angle, order always matters. This means I must know two angles, and since the S is in the middle, the side must be included between those two angles I know information about. So looking at just the information they give us, not assuming anything else or making any assumptions or figuring out anything else, the way this is written, you cannot use angle, side, angle. The reason is for us to use angle, side, angle, here's an angle, here's an angle, the included side has to be between those. So I would have to know this side length here. So the wrong piece or the wrong side is the one we know information about. So why the side we were given is not included. So we can't use angle, side, angle again with just the information we were given because the side we were given information about is not included between the two angles. Moving to question 19, in the diagram below, triangle ABE is similar to triangle CDE. Using the properties of similar triangles, find the measure of side AE, showing all of our work. So really, we're being asked to find this long distance right here from A to E. We're going to set up a proportion. So I know when we did this a couple weeks ago, we made two separate triangles. So we're going to go ahead and do that again, just so we can see what's happening. Good enough. So I'm going to separate these two triangles. I'm going to do the little one here. So the little one we know has this side 10, this side 12. We don't know anything about the bottom. For the big triangle, we know that the left side's 15. The right side over here is what we're trying to figure out. So we're going to create a proportion using these four numbers. Keeping in mind, we always want to be consistent. So if I make my first fraction, I'm going to start left side. So I'm going to start left side of the little triangle's 10, divided by left side of the big triangle, 15. So left side of the little divided by left side of the big. And then I'm going to move to a different side, but I have to remain consistent. I started with the little triangle on top, so I'm going to do right side of the little triangle is 12, right side of the big triangle is x. So I've made my proportion. 10 over 15 equals 12 over x. And then I'm just going to cross multiply. So these two get multiplied together. 10 times x is 10x. And then these two get multiplied together. 12 times 15 is 180. So 10x equals 180. To get x by itself, I'm going to divide both sides by 10. 180 divided by 10 is just 18. So the measure of side AE is 18 units. Questions on this one? All right, question 19. In the diagram below, we have two similar triangles. The first thing we're being asked to do is complete a similarity statement. So first thing we were given is MLN. So we started cubes here, down this side to L, down this side to N. So it looks like if I had to choose, this side's my hypotenuse. It looks like the longest side of my triangle. Same way with this one looks like my hypotenuse. So when I start, I'm at the side between the unknown angle and the hypotenuse along the longer side. So longer side, hypotenuse, this one. So if I pick the vertex C that I think corresponds with M, it would most definitely be R. The middle letter we were given is L. L's marked 80 degrees, so really I just have to look and figure out which one's 80 degrees in the second triangle. That's Q. So in the second triangle, Q is 80 degrees, so it's got to correspond with L. L is in the middle. Q must be in the middle in my similarity statement. And then the last letter must be S. On both of these, S and N are both between the shortest side and the hypotenuse. Part B says circle the way that you can prove these two triangles below are similar. In this case, to prove them similar, first thing it's asking us, can you prove this by angle, angle? Can you prove two angles in one triangle are congruent to two angles in another? Well, when I look at the information I was given, I only know information about one angle. Since I only know information about one angle, I can't prove by angle, angle. For the second option, I have side, side, side. If I'm proving with side, 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 I must know information about all three sides of both triangles. I know nothing about this side, and I know nothing about this side, which means I cannot prove these similar by side, side, side. Which means I really only have one option, side, angle, side. So it's got to be side, angle, side. We do know two sides and the included angle. So we're definitely going to use side, angle, side. Part C, we're asked to solve for x. Really, that's a fancy way of saying, hey, create a proportion like you did on the last question. So I'm going to start with the shortest side on the left triangle. Shortest side on the left triangle is 3. So that's this right here. Shortest side on the right triangle is this 6 up here. So it's going in the denominator. So I've got 3 over 6 equals, then I'm going to go to a different side. In this case, I'm going to go to this side right here. 4 divided by its corresponding side, 4x minus 8. So just be consistent. I started little triangle divided by big triangle, little triangle divided by big triangle to remain consistent. Then we're going to cross multiply. I'm going to take these two and multiply them together. 6 times 4 is 24. And then I'm going to do the other diagonal. Be mindful when I do this diagonal, the 3 gets multiplied by the 4x and the minus 8. So 3 times 4x is 12x. And 3 times negative 8 is negative 24. Now in the past, I've had students want to cancel these 24s out. You can't cancel them out. They're on opposite sides of the equation or the equal sign, and they have opposite signs. So you're going to either add or subtract them to get them together. In this case, I would add 24 to move this one to this side, which really gives me positive 24 plus 24, which is 48. So now I have 48 equals 12x. 12 is being multiplied by x, so divide by 12. And x equals 4. That's all you were asked to do, so that actually is your final answer, x equals 4. Questions on this one? Question 22, what is the trig ratio for sine of c? So you might want to jot down your shortcut, for your trig functions, SOHCAHTOA, SOHCAHTOA. So sine is opposite divided by hypotenuse, cosine is adjacent divided by hypotenuse, and t is tangent is opposite over adjacent. So in this case, we're asked for the sine of c, so we're going to use SOH. That means the sine of the angle, so sine c, is going to equal whatever is opposite divided by whatever the hypotenuse is. So you have to go through and label your triangle based off the angle that you're talking about. So everything's going to be based off angle C. According to angle C, opposite I think tends to be one of the easier ones. Opposite means it can't touch it. So the only side that's not touching angle C is AT, which is 24. So I'm going to label that opposite. The next thing I always label is the hypotenuse. The hypotenuse is always the longest side. In this case, the 25. And then the last thing you have left must be the adjacent side. Adjacent is touching the angle, but not the hypotenuse. So now we've labeled them, then we're just going to go back and fill them in. So sine of C equals, well, what number did we label opposite? Yep. So we labeled opposite as the side AT, which was 24. So I'm plugging in 24. Then for my hypotenuse, we labeled the hypotenuse was the 25. This was all we're asked to do. We're asked to find the ratio for sine C. So sine C is the ratio, 24 divided by 25. That's it. Nothing goes into your calculator. You're not evaluating anything. That is your final answer. Questions on that one? Question 23 says, find the missing side x, round your answer to the nearest hundredth. So like the last one, we're given one angle here. We're given angle C, which is 52 degrees. You never use the 90-degree angle. So we're going to label things based off of the 52-degree angle. So based off the 52-degree angle, if I go opposite, I get to 12. If I label my hypotenuse opposite my right angle, so x is the hypotenuse, 12 is the opposite. Technically, this is my adjacent side. But we don't know anything about the adjacent side, and we're not trying to find anything out about the adjacent side. So I'm going to use, again, opposite and hypotenuse, which is going to tell me I have to use sine. So now we were given an angle measure, so instead of writing sine C, we're going to write sine of 52 because that's the angle we're talking about. And that's going to equal opposite divided by hypotenuse. Well, the opposite side we labeled as 12. the hypotenuse was the x. So this is one of the tricky ones. You got to get that x out of the denominator, multiply both sides by x. So now you have x times the sine of 52 equals 12. To get x by itself, you've got to get rid of this whole sine of 52 by dividing by it. So in your calculator, you're going to write, or type, I should say, 12 divided by the sine of 52. That gives you an x value of 15.23. Again, it tells you to round to the nearest hundredth place, so 2 places after your decimal. Questions on this one? All right, one more. So I know we've completed a question really similar to this. So we're talking about a house. We want to know how far from the base of the house do we need to put a 12-foot ladder so that it exactly reaches the top of a 12-foot wall. So here's my house, here's my ladder. We have a 12-foot ladder, so this is 12 foot. And we know the house is 10 foot tall. We want to figure out how far this has to be. This is just a fancy way of giving you a Pythagorean theorem problem. So we have a right triangle. We know the hypotenuse, and we know one of the legs. So we're going to use a squared plus b squared equals c squared. Make sure your hypotenuse must be plugged in for c squared. So that hypotenuse, you're going to have to take 12 squared on that side. The other two don't matter. So I'm going to leave it as a squared plus 10 squared equals 12 squared. So then I'm going to square both terms. 10 squared is 100. 12 squared is 144. So now I have a squared plus 100 equals 144. Subtract 100 from both sides. A squared equals 44. To get rid of that squared, so we don't want to know what a squared equals, we want to know what a equals. So we're going to square root both sides. Squared and square root cancel, leaving us with a on the left side. And then I'm going to type in my calculator the square root of 44. And it gives me approximately 6.6 feet. So since this is a word problem, I am going to label my answer feet, because we're talking about how far a ladder should be from the base.